Let's get ready for another deep dive. Today we're going deep on polynomials and factoring,
Oh,
a
yeah.
topic I see you've been brushing up on in your notes.
Yeah, definitely a good one.
Looks like you're getting ready for round 2 with algebra.
Round 2, exactly.
And we're here to make sure you come out on top this time.
We'll make sure you're ready.
We're going to cover all the essentials, adding, subtracting,
The
multiplying,
core.
and then, of course, the big one, factoring itself.
Gotta get that factoring down.
You know, it's funny how polynomials, at first glance, can seem kind of like abstract.
Yeah, they do.
But you know what? They're actually like the foundation for so much of what we see and experience around us.
Absolutely.
And I saw in your notes you were curious about like how they're used in physics.
Yeah.
So think about launching a rocket, right? To calculate its trajectory. You know how high it goes over time, how fast it's going?
Mm-hmm.
All while taking into account things like gravity and thrust.
Right.
You'd use a polynomial equation for that.
Yeah, that's exactly right.
Right. Pretty amazing.
It is pretty cool.
So it's not just, number crunching. It's about really understanding like the language of how things work.
It is. It's like the language of physics.
Right. But before we, launch ourselves into rocket science, I think we should probably define what a polynomial actually is.
Yeah, for sure. Let's ground ourselves a bit.
Back to basics.
So in the most simple terms, you can think of a polynomial as a mathematical expression, kind of like a sentence made up of variables, those x's and y's we see,
Right.
and constants like 2 or -5. And you combine them using operations like addition, subtraction, and multiplication, and it all has to follow certain rules. It's not just random.
Okay, so like 3x exposed plus 5 by 1, that would be a polynomial.
Yeah. You got it. That's a perfect example. You have your variable x, your constants 3, 5, and more and 1, and they're all connected with plus and minus signs.
All right, I'm with you.
Cool. So now that we've got that down, let's move on to those basic operations. I noticed in your notes that you had circled a problem about subtracting polynomials. I think it'll be really helpful to work through that one together.
Yeah, I think that's a good one to start with because sometimes all those terms, it's just like a jumbled mess.
It can be.
It can be tough to keep track of everything.
But don't worry, it's all about organization.
Okay.
The key is to combine those terms, which are terms that have the same variable raised to the same power. So it's like sorting, apples and oranges. They have to be the same kind of fruit to go in the same basket.
Right.
Like, for instance, if we have 2x senso plus 3 by 5 foot minus xxx plus 2, imagine we have different baskets, one for x, one for x, and one for those plain numbers, the constants.
Okay.
You put your x's together, your x's together, and your constants together, just like organizing fruit. And in the end, you'll get x side L plus 4 by 7 foot.
Oh, I see.
Yeah.
That's a good way to look at it, yeah.
The baskets help.
It does help to visualize it.
It does.
Now, what about multiplying polynomials? I mean, that's like a whole other level, right?
Yeah, it might seem a bit more challenging, but the core concept is actually pretty straightforward.
Okay.
It's all based on the distributive property, basically the idea of sharing.
It's sharing.
Yeah. You multiply each term in one polynomial by every term in the other polynomial. Think of it like making sure everyone at a party gets a chance to chat with everyone else.
Okay.
That way, no term feels left out. And it makes the whole process more systematic.
I like that analogy. It makes it feel less like random.
Right. Less chaotic.
More organized.
Exactly.
And I noticed you highlighted special products in your notes. What's so special about them?
Oh, those are great. They're like patterns that pop up when you multiply certain types of polynomials, and they can seriously save you time if you recognize them.
Oh, okay.
And the difference of squares pattern, the one you mentioned, it's a classic. It basically states that a plus b multiplied by ab will always equal ab. So if you encounter something like x plus 3 by 3, bam.
Wow.
Right away that simplifies to x soar at 9. No need to go through all the steps of distributing.
Wow. That is handy.
It's like having a cheat sheet.
A shortcut.
Exactly. And the better you get at spotting these patterns, the faster you'll be at factoring too, which is where we're headed next.
Factoring? Okay. So that's where we kind of like reverse engineer the multiplication, right?
Got it.
It's like we built that rocket. Now we're going to take it apart and see how all the pieces fit together.
Exactly. And just like there are different types of rockets, there are different techniques for factoring polynomials.
Right.
We've talked about the difference of squares, and I saw in your notes you're interested in factoring trinomials, those expressions in the form of x plus bx plus c.
Yeah. Yeah. Those always kind of stump me.
I know, they can be a bit tricky.
Yeah.
But think of it like a puzzle.
Yeah.
You got to find two numbers that add up to b, which is the coefficient of your x term, And those same two numbers have to multiply to give you AC, which is the product of the leading coefficient and the constant term.
Okay.
It takes some practice, a bit of trial and error.
Right.
But as you get the hang of it, it becomes more intuitive. You start seeing the patterns.
So it's almost like we're unlocking a code.
Yeah, exactly. You're breaking the code hidden in the polynomial.
And these solutions, these numbers we find, they're not just abstract, are they?
No, not at all.
They have real-world applications.
Oh, definitely. Like in engineering, for example.
Yeah.
You might use factoring to figure out the best dimensions for a bridge support beam to make it as strong as possible.
Wow. So we've gone from launching rockets to building bridges.
All thanks to polynomials.
All thanks to polynomials. It's amazing. Before we wrap up this deep dive, any final thoughts? Like something for a listener to really ponder?
Yeah, absolutely. I think the main takeaway here is that understanding polynomials and factoring, it's not just about acing your next algebra quiz. It's about unlocking these powerful tools that can help you, analyze and understand how things work.
Right.
You can model and solve problems in so many different areas.
It's a real-life skill.
It really is. From science and engineering to even economics and finance. The more you explore these concepts, the more you'll discover just how far they can take you.
That's a great point to end on.
I think so.
So keep exploring, keep diving deep.
Exactly, and happy factoring.
Yeah.